We're going to learn about a new method of solving systems today. It's called the substitution method because we'll be doing a lot of substituting in this, so it's not very creative name there, but it's effective. So we'll talk about substitution like we did a little bit in class about when to use it and what actually is substitution. Those are the things we covered today during class as a little bit of a preview for this assignment. So hopefully you have those notes written down. And we take a look here at our first example. Solve negative x plus y equals 1 and 2x plus y equals negative 2. So the first step is that we want to solve an equation for one of the variables. And we want to solve it for one that has a coefficient of 1. What's nice about this first example is there's 3 variables, the negative x, the y, and the y, that all have a coefficient of 1. So we have different options. That means there'd be a bunch of different ways that you guys could all solve this on a test or a quiz, but we'll all do it the same way here as we go through this problem. So we look here. I'm going to take, just simply because it's at the bottom here, I'm going to take this bottom equation and I'm going to solve it for y. And in order to get y by itself, I need to subtract the 2x from both sides, because 2 minus 2x, 2x minus 2x will make that left side 0. So we end up with y is equal to negative 2x minus 2. So I have found that to be y. So that's my first step that we just completed right there. Okay, we've done that. So what we need to do is we need to take this expression, okay, and specifically the negative 2x minus 2 there, and we need to substitute it into the other equation, so that first one. So what we'll have in that first one is we have negative x plus y, but we're going to write y as negative 2x minus 2 equal to 1. So we substitute the expression from step 1 into the other equation. So we've done that. So now what's nice, and that the purpose of substitution, is to get the equation to have one variable. So now we have x as our variable. We don't have x and y together. Now this becomes an equation that we solved way back at the beginning of the year. So we just have to solve this. This will be x minus 2x minus 2 equals 1. Well, negative x minus 2x is negative 3x minus 2 equals 1. We have to add 2 to both sides. We get negative 3x is equal to 3. And the inverse of multiplying is dividing, so we have to divide both sides by negative 3. We get x equals negative 1. So we've completed step 2. We solved this equation for the variable. We got x equals negative 1. Now we have to complete the third step, which is to substitute the value of x equals negative 1 back into the equation to get the other variable, the y variable. So in this case, we have y is equal to negative 2x minus 2. Well, x is negative 1, so this is negative 2 times negative 1 minus 2. So that's positive 2 minus 2. We end up with y is equal to 0. So our solution is negative 1, comma 0. So we've completed all 3 steps. We got our ordered pair solution to a system. This is a very good example. Make sure you have it down and continue to refer back to it. There's a lot of good stuff in this problem. We'll take a look at these. Not going to go through the step-by-step explanation so much, as we are going to go through and solve them as you would if you saw these maybe tomorrow during class as practice. So if we take a look here on the left, this one we only have one variable that has a coefficient of 1, and that's this x here, so we're going to need to solve for it. So that means I'm first going to have to add 4y to both sides of the equation. So that leaves me with x equals 4y minus 1. So this is going to go back into the top equation. It'll leave us with 2x. I'm sorry, scratch that. Got to erase here. Let's think of the other problem again. We know x is equal to 4y. So we're going to have 2 times the quantity 4y minus 1 plus 2y equals 3. So again, after we substitute, we have one variable, we only have y, and we solve it like a regular equation from earlier this year. 8y minus 2 plus 2y equals 3. Combine like terms on the left side, 8y and 2y is 10y. We still have the minus 2 equals 3. From here, we'll need to add 2 to both sides. 10y is equal to 5. And we divide both sides by 10. We get y is equal to 1/2. So we'll need that as part of our solution. So from here, we come back and we solve that into this x equals 4y minus 1. Y is equal to 1/2. So 4 times 1/2 is 2. 2 minus 1 is 1. That gives us an answer, final answer of 1, 1/2 as our solution to this problem, to this particular one. We're going to go ahead with this last example. What's nice about this is that this second equation here is already solved for x. Now, that's really nice, but I don't know what the reason is. I hopefully someday I figure it out. These ones typically trip us up at first. So what's nice, it's also what makes us think it can't be that easy. This equation is already solved for x. So what we do is we substitute that in up top. So x is equal to 2y. We plug that in there. And then we still have our 6y here equals 15. 2 times 2y is 4y plus 6y equals 15. 4y and 6y is 10y equal to 15. Divide both sides by 10. We end up with y is equal to 3/2. Also, it's nice when we go back to substitute, again, that was already done for us. X is equal to 2 times 3/2. That ends up being 3. So our final answer is 3, 3/2. So there's 3 examples of solving systems by substituting. Obviously, we're going to do countless more over the next couple of days. Please make sure you have your questions ready tomorrow when you come into class. Have a great night. We'll see you tomorrow.